Hello friends, here in this video we will see a problem on maximum axial pull and total elongation. So here we have a question. A circular bar of 500 mm length has a cross section as given below. First 100 mm length has a diameter of 12 mm. Second 200 mm length has a diameter of 20 mm. And last 200 mm has a diameter of 30 mm. So we can see that this 500 mm is divided into 100 mm, 200 mm and then 200 mm, each having different diameters. So the bar which is given in the problem, it is called as a stepped bar. Next, determine the maximum axial pull which the bar may be subjected if maximum stress is limited to 100 Newton per mm square. Find total elongation. Take capital E is equal to 2 into 10 raised to 5 Newton per mm square. So this is the question we have in front of us. Let us try to get the solution for this problem. If we look into this question, there are two unknowns here. First is we have to find out what is the maximum axial pull. Maximum axial pull, we will denote it by letter P, which the bar may be subjected, and we have to even find out total elongation. Total elongation is delta L. So these are the questions in front of us. Next, when we are trying to solve this problem, since the length has been divided into three parts having three different diameters, so first it is necessary that we start drawing the diagram. So here first 100 mm has a diameter of 12 mm. So I would be drawing the step bar. This is the first 100 mm having diameter of 12 mm. Next, second 200 mm has a diameter of 20 mm. So diameter increases from 12 to 20 mm for the second part of this stepped bar, and even the length is more here. Then last 200 mm has a diameter of 30 mm. So after 20 mm the diameter goes up to 30 mm. So here we have this stepped bar. I'll mark the length and respective diameters. The first length is of 100 mm. Next it is of 200 mm. At last again we have a length of 200 mm. Now these different lengths, they also have different diameters. So here the first section it has a diameter of 12 mm. Next section it has a diameter of 20 mm. At last we have a diameter of 30 mm. So here what I will do, I will divide this stepped bar into three parts. Diameter 12 mm will be the first part for us. Next this will be second, and here third part. Then I'll read the question what is given next. Determine the maximum axial pull. So here it is mentioned that this bar is being pulled by applying tensile force on both the sides. So this is a pull type of load here. Next, which the bar may be subjected if maximum stress is limited to 100 Newton per mm square. So sigma max is given, that is the maximum stress. Now, since the first question is we have to find out the maximum axial pull, what we can do in this problem is, after we have determined the three sections, we can calculate their individual areas. So I'll say that since cross sectional area for all sections is given by cross section area for the first section, that will be A1 is equal to pi by 4 into diameter square. Here the diameter is 12, so it is 12 square, and this value comes out to be the answer which I have. It is 113.097 mm square. So this is the first area. Next area for the second section, that will be pi by 4 into 20 square. So this comes out to be 314.16 mm square. Then area for the third section, area 3, is equal to pi by 4 into 30 square, and this is 706.86 mm square. So these are the individual areas we have. Next, after getting these areas, the first question is we have to find out the maximum axial pull, and in this problem they have given the value of maximum stress. Maximum stress in this problem, it is given as 100 Newton per mm square. Now, this maximum stress will be acting at a region where the area is minimum, because stress is inversely proportional to area. So stress will be maximum where area is minimum, and as we can see, out of the three sections, the first section has a diameter of 12, so here the area is minimum, we can see. So I can say that the maximum stress would be acting at section 1. So next I can say that now, since maximum stress will be acting at minimum cross sectional area, so therefore I can find out the maximum stress. Maximum stress sigma max is equal to the maximum axial pull upon cross sectional area, and here the area I would be taking it as area 1, because area 1 has the least value and here the stress will be maximum. So therefore P will be equal to sigma max into area 1. Here in this problem sigma max is given as 100, area 1 is 113.097. So therefore the value of P, it comes out to be, it is 113, or we can say it is 11.309 into 10 raised to 3 Newton. So now, after getting the value of load, here we can say that this is the maximum axial pull which is applied at the stepped bar, and this is answer number 1 for us. Now, in this question we have to find out the maximum axial pull and total elongation. So the first part is over. We have calculated the maximum axial pull. Now total deflection. For total deflection, here as we have a stepped bar, we will calculate deflection in the first section, in second section and third section. After finding these three deflections, we are going to add them to get the total elongation of this bar. So let us start with this from the first section. Since elongation in section 1 is given by, the formula of elongation is delta L1, I'll write it since it is for the first section, is equal to PL upon AE. I'll highlight this formula. So therefore, deflection in section 1, P is the maximum axial pull. It is given as 11.309 into 10 raised to 3. Length of the section, for the first section the length is 100 mm. Area of the first section, we have found out it was 113.097. 113.097 into Young's modulus is given in the question. Its value was 2 into 10 raised to 5. So from this, if I calculate, I'll get the deflection in the first section and my answer is 0.05 mm. So this much is the deflection in the first section. Similarly, we are going to calculate the deflections in second and third section. So here I'll write down deflection in section second is given by delta L2 is equal to PL upon AE for the second section. So therefore, deflection is equal to maximum axial pull. We have calculated it was 11.309 into 10 raised to 3. Length of the second section, it is 200 mm. Area, it was 314.16 into Young's modulus, 2 into 10 raised to 5. So from this I'll get the deflection in the second section and my answer is 0.036 mm. After getting the deflection in the second section, next is I'll write down deflection in section 3 is given by delta L3 is equal to PL upon AE. Since we are finding for the third section, so I am adding suffix 3 here. So here I'll go on putting the values. So therefore delta L3 is equal to P is 11.309 into 10 raised to 3. Length for the third section, it is 200. Area, it is 706.86 and Young's modulus is 2 into 10 raised to 5. So here my answer is 0.016 mm. So after getting these three deflections in three different sections of the step bar, we will add them up to get the total elongation. So after this I'll write down Therefore, total elongation is given by delta L is equal to delta L1 plus delta L2 plus delta L3. So here I'll get the total elongation. Therefore, delta L is equal to delta L1 0.05 mm, delta L2 0.036 mm, delta L3 0.016 mm. So after adding this, I'll get the answer as 0.102 mm. This is my second answer. And total elongation, here there is an increase of length of the bar because this answer is positive. If this answer would have been negative, it means that the bar is compressed and the length is reduced. But here in this case, since the stepped bar is pulled, the length of the bar would be increasing by 0.102 mm. So in this video we have seen how to calculate the maximum axial pull and deflection of a stepped bar.